Okay. Good afternoon, students.
Good afternoon, ma'am.
Yeah. So with the last class, we finished the chapter electricity. Is there any doubt regarding with the chapter electricity?
It is finished.
Yes, it's finished. The last class we discussed about the electric power and electric energy, right?
Yes, I'm electric bulb tungsten.
Did we complete the electric energy?
Ma'am, not thinking. We didn't take electric energy, and we
We are
take
not
the.
discussed the electric power and electric energy.
We take the electric energy. That
Yeah, electric power. What do you mean by electric power? Gauri, electric power.
The rate at which electric energy is being consumed or it gets dissipated in an electric circuit.
Yes, it is the rate at which the electrical energy is consumed. It can be either consumed or dissipated outside in the form of heat energy. That is what is known as electric power. So from an electric circuit, sometimes the electrical energy is consumed, or in some cases, the electrical energy is dissipated outside in the form of heat. That is what is known as electric power. And which letter is used to represent electric power? Aaron Jose. Which letter is used to represent electric power? Same question to Dominic. How we can represent electric power? Yes, Eva, right. We are representing the electric power with the P. And what is the mathematical equation for calculating electric power? Navaneet, mathematical equation for calculating electric power.
ma'am.
Yes, Shania, right. P is equal to VI. Electric power is the product of potential and current. P is equal to VI. Then what is the SI unit of electric power? ELSA. SI unit of electric power. Except ELSA, others are give the answers in chat box. What about the SI unit of electric power? Raya, SI unit of electric power? What is the SI unit of electric power? So other than this equation P is equal to VI, we have two more equations are there to calculate the electric power. Revu, how we can calculate the electric power that is generated in an electric circuit if the term voltage is not given? How we can calculate the electric power if the term voltage is not provided in the question? Yes, Eva, unmute and say. How we can calculate the electric power if the voltage is not provided?
P equal to IR square.
Not IR square, I
square
square R. P is equal to I square R. Then again, Sania, what is the equation for calculating the electric power if the value of current is not given?
P is equal to V square by R.
Very good. P is equal to V square by R. Then what do you mean by electric energy? Angelo, electric energy.
It is a product of power and time.
Very good. It is the product of power and time. Product of power and time is known as electrical energy. There is no special letter is there to denote this electric energy. We write this electric energy as it is. Electric energy is equal to power into time, P into T, or in simply we can say electric energy is equal to PT. Okay. Then what is the SI unit of electric energy? Melita, SI unit of electric energy. Electric energy is the product of power and time. Okay. So what is the SI unit of power? SI unit of power is watt and the unit of time is hour. So the combinedly we can take the SI unit of electric energy is watt hour. Okay, watt hour. But this watt hour is, we can use this watt hour to measure a small units of electrical energy. So for commercial purpose, we are using one more unit. What's that? What is the commercial unit of electrical energy? Alna, commercial unit of electrical energy. Yes. Same question too. Here Shania say the answer in chat box. Anthony, What is the SI unit of electrical energy? Same question to Roshan. Okay, Melita. It is, what is the SI unit of electric energy? Not SI unit, commercial unit. Commercial unit of electric energy. Yes? Electric energy is the product of power and time. Okay. So it is watt hour is the simple SI unit of electric energy. But for commercial purpose, we use a large unit of electric energy. It is kilowatt hour. This kilowatt hour. Okay. I think most of your audio is not working. Is there any problem with your mic?
No, ma'am,
All
no
of-
problem.
No problem. All of them are give the answers in the chat box. That's why I'm asking. Okay. So once again, we can make a quick revision of this chapter, electricity, from the very beginning. So starting with Isha. What do you mean by electric current? Electric current. Abin Thompson. Elect-
Flow.
Who said the answer? Fizan?
I
Yes, Fizan. What do you mean by electric current?
Rate of flow of charge, current.
Rate of flow of charge. Rate of flow of charge is known as electric current. Very good. Then Abin, what is the mathematical equation for calculating the electric current? Mathematical
Ma'am.
equation.
Ma'am,
Yes.
A is equal to Coulomb by second.
Current.
I is
There,
equal to
I is equal to?
Q by T.
Very good. I is equal to Q by T. Good. Then Jesslyn, SI unit of electric current. SI unit of electric current. Srihari, I need the quick answers from you. This is a rapid fire round for the electricity. Ampere. Ampere is the SI unit. Which device is used to measure the electric current? Question is to Anjali Priya. Device used to measure the electric current.
Ammeter.
Very good. Then the next question is to Rachel George. How we connect the ammeter to an electric circuit? The mode of connection of ammeter to an electric circuit. Fizan, say the blunder answers here.
But I didn't hear the
How we
question.
connect the ammeter to an electric circuit? Who know the answer?
How we connect?
Series.
Yes, very good. Ammeter is always connected series to an electric circuit. Then we can move to the potential difference. So the next question is to Rohan Raj. Rohan, what do you mean by potential difference? Potential difference.
Yes, ma'am.
What do you mean by potential difference?
Occasionally,
Oh yeah, try to say the equation.
two
Potential difference. Potential difference is also known as voltage. What do you mean by voltage? Equation for voltage.
V
V is equal to?
W V W is equal to V by Q.
No. V is equal to W by Q. Okay, V is equal to W by
W
Q.
by Q.
Delvin, it is not R, W by Q, because potential difference is the work done to bring the charge from one point to another point. This is the work done to bring the charge from one point to another point. So we can say V is equal to, potential difference is known as voltage. V is equal to W by Q. So if you are not remembering this definition, you just try to recall the equation where W is the work done, Q is the charge. So it is the work done to bring the charge from one point to another point. That is what is known as potential difference. Okay. Then again, the next question is to Gautam. What is the SI unit of potential difference? SI unit of potential difference. Gautam, are you here? No. Kshetra, SI unit of potential difference. Sean.
And Gautam is
Okay, Gautam. What is SI unit of potential difference? I think he's faced some kind of network issues. Sean, same question to Sean.
Ma'am, volt.
Volt. Very good. Then the next topic, Ohm's law. Who is ready here to state the Ohm's law?
IR. I is equal to IR. V is equal to IR.
Say any one law.
V is
I
equal to
need
IR.
the law that is stated by Ohm, not by Fizan.
Eh?
Ohm's law.
Equation.
Delvin, Ohm's law. State Ohm's law.
I said equation.
Yeah, what is the equation representing the Ohm's law?
IR.
V equal to IR. Then what is Ohm's law state? Lena, Ohm's law.
Yeah.
Is a rate of current flow through a wall.
Ohm's law, V is equal to IR. Delvin, try to state the Ohm's law.
At a constant
Oh, yeah, it's right.
temperature, the potential difference V across the ends of a conductor
Conductor is
electric in an electric circuit
okay.
is directly proportional to the current flowing through.
Yes, it is directly proportional to the current that is flowing through the circuit, right? So according to Ohm's law, we know that V is equal to IR. That is the potential difference across the ends of a conductor is directly proportional to the resistor when the temperature remains a constant. So that is the condition that we need to satisfy here. If we are providing a constant temperature, potential difference is directly proportional to the resistance of the conductor. Okay. Next question is to Jesslyn. What are the factors affecting the value of resistance? Factors affecting the value of resistance. Same question to Navaneet. Factors affecting the value of resistance.
If current increases, resistance
You
decreases.
only need the four factors. You don't need to explain the entire phenomenon and all. What are the four factors affecting the value of resistance? Ah, yes, Devasena. Unmute and say. It's right.
Ma'am, temperature.
Temperature. Three more factors are there.
Yes, ma'am.
Yes. Yes, Melita, it's right. Length of the conductor, temperature, area of cross section, and one more factor is there. What's that? Nature of the material. Nature of the material. And then what are the combination of resistors? We have two combination of resistors are there. What are they?
Series and
Raya.
parallel.
Series and parallel. Then Raya, what is the equation for calculating the total resistance in a series combination? R is equal to R1 plus R2 plus R3. Okay, good. Then Emerin, what is the equation for calculating the total resistance in a parallel combination?
I know. V1 is equal to V1 plus V2.
Are you Emerin Fizan? Emerin. What is the equation for calculating the total resistance in a parallel combination? Okay, Fizan, you can say now. What is the total resistance offered by parallel combination?
Is equal to V1 plus V2 plus V3.
Total resistance. Resistance is represented by the letter R, not by V.
R is equal to R1 plus R2 plus R3.
That is about the series combination. So my question is about parallel combination.
R is equal to R1 by R2 plus R2.
Yes, Anjali, it's right. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So if the combination consists of mainly three resistors, then we can calculate the effective resistance using the equation 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So that's all about the total picture of the chapter electricity. So I hope that most of them know the theoretical part and equations and all. So now we can just try to solve some problems and equations based on this chapter. I think it is better to classify the, divide the entire class into two groups, girls and boys team. Are you ready?
Yes.
Okay. So we have boys team and girls team.
And how much mark is winning mark?
If you say the answer, you can score 1 marks. Otherwise, the same question passed to girls team. Okay. If you
Okay.
say wrong answer also, then also the point goes to girls team. Okay.
That how?
Now we can start. So the first question is to girls. What is mean by 5 ampere? What do you mean by 5 ampere? Question is it is not there, Eva, in the textbook. It's an external questions. Try to go through the options. A charge of 5 coulomb flows through a point in 1 second. 5-volt electricity flows across 1 ohm of resistance. 5-volt electricity is causing 1 coulomb of charge to flow. A charge of 5 coulomb flows through a point in 5 seconds. What do you mean by 5 ampere?
I can ask doubt.
Yes.
What is inversely means?
Inversely proportional. We have directly proportional and inversely proportional. Directly proportional means if one quantity increases, the other quantity is also automatically increases. Inversely proportional means if one quantity increases, the other quantity decreases.
Okay.
Girls team, here you have the first question. What do you mean by 5 ampere? Which is the correct option? Option A, B, C, or D? 5 ampere. What is the equation for calculating the current? Girls team, do you know the answer? Anyone? If you know the answer, unmute and say. A charge of 5 coulomb flows through a point in 1 second. A 5-volt electricity flows across 1 ohm of resistance. 5-volt electricity is causing 1 coulomb of charge to flow. A charge of 5 coulomb flows through a point in 5 seconds. Okay, now the time is over. The question passed to boys team.
And current question now.
Yeah, what is the right option here?
A charge of 5 coulomb flows through a point in 1 second.
A, B, C, or D?
A.
Option A. A charge of 5 coulomb flows through a point in 1 second. Right. So here the boys team scores the 1 marks.
And can we discuss now with
Yeah, of course, no problem. What is the equation for calculating the current? Equation for current? I is equal to
W by Q by
I is equal to Q by T.
Q by T.
Because electric current is the rate of flow of charge. The rate of flow of charge is known as electric current. I is equal to Q by T. So here in the question, they are given that what do you mean by 5 ampere? 5 ampere current means a charge of 5 coulomb that is flows through a circuit or through a point in 1 second. Then only we get 5 ampere current. 5 by 1 second. So the option 1 will be right. According to a second option, 5-volt electricity flows across 1 ohm resistance. It is not our equation. The equation for the current is I is equal to Q by T. Or according to the last option, a charge of 5 coulomb flows through a point in 5 seconds. Then it will become 5 divided by 5, that is equal to 1 ampere. But we need 5 ampere. So the correct option is option 1. A charge of 5 coulomb flows through a point in 1 second. I is equal to Q by T. So 5 ampere is equal to 5 coulomb of charge that flows through a point of in 1 second. In 1 second. Okay. Now the next questions to boys. On what factors does the heat generated in a conductor depend upon? On what factors does the heat generated in a conductor depend upon? Directly proportional to time, inversely proportional to time, directly proportional to density, inversely proportional to mass. If you know the answer, unmute and say. Okay, then question goes to girls
Ma'am.
team.
Now,
No, your time is over. Girls,
Option 1.
if you know the answer, unmute and say girls. Otherwise, both the teams score 0 marks.
And directly proportional to time.
It is directly proportional to time. Can you say the equation? On what factors does the heat generated in a conductor? What is the equation for heat generated? How we can calculate the heat generated in a conductor? How we can calculate the heat generated in a conductor?
Check out I square.
Yes, H is equal to I square RT. H is equal to I square RT. The very famous Joule's law of heating effect. Okay, so according to this equation, we know that heat generated in a conductor is directly proportional to square of the current. Heat generated in a conductor is directly proportional to resistance of the conductor. Heat generated in a circuit is directly proportional to time. So the first option is right. So here girls team scores 1 marks. The next question against to girls. What is the power of an electric lamp if it draws 20 ampere current when connected to 220 volt line? What is the power of an electric lamp if it draws 20 ampere current when connected to 220 volt line? Is it 110 watt, 240 watt, 4400 watt? None of this. What is the power of an electric lamp if it draws 20 ampere current when connected to 220 volt line? 220 volt line. Power. Do you know the answer?
Option C.
Option C. Is it right? What about boys? Is it right?
And we want to do
Okay. How we calculate the power generated in electric circuit? What is the equation for calculating the power, electric power? Yeah, P is equal to VI. P is equal to VI. What is the volt? It's already given in the question. 220.
220 volt.
220 into current. To draw say current is equal to 20 ampere. So 220 into 20. So it becomes 22 into 2. 220 into 2, it becomes 4400 watt. So option C is right. Again, girls team scores 1 mark. Next to boys. You are given 3 resistances of 2 ohm, 4 ohm and 6 ohm. What will be the equivalent resistance if they are connected in series?
12.
12 ohm. Yeah, right. So here we have 3 resistors are there with resistances 2 ohm, 4 ohm and 6 ohm. They are connected in series. What about their equivalent resistance? Equivalent resistance means effective resistance or total resistance of the circuit. So in a series combination, the equivalent resistance is given by Rs is equal to R1 plus R2 plus R3. that is equal to 2 ohm plus 4 ohm plus 6 ohm. So the answer will be 12 ohm. Very good.
1.4.
Oh, okay, Fisan. You are given three resistances of 2, 4, and 6 ohm. What will be the total resistance if they are connected in series? Now you are in equal in your points. 1, 1. Sorry, 2, 2.
Other question.
Our equivalent resistance become 12 ohm. Now the next question is to girls. Is it over?
Right.
Okay.
I'm question doing right only answer. Ma'am, can I send the question?
Yeah, you need this slide.
Yes, ma'am.
Okay.
So when write full that way, full question that.
No problem. I will send it in the class group.
Then you can run.
Okay. So try to copy down the question and work out it by yourself. And if you find any doubt regarding with these questions, you can ask me. Next is to girls. The same resistors with resistances 2 ohm, 4 ohm, and 6 ohm are connected in parallel. Now they are connected in parallel. Then what will be the equivalent resistance? Yes. The question is to girls. Okay, no problem. Three resistors with resistance 2 ohm, 4 ohm, and 6 ohm are connected in parallel. Then what will be their equivalent resistance? Yes.
2.2.
Is it 1.2 ohm?
No.
So you lost the mark. The same question passed to boys. Equivalent resistance if they are connected in parallel.
Ma'am, D.
B.
D.
D. Okay. Yeah, it's right. How we can calculate the equivalent resistance in a parallel combination? What is the equation?
By R1 plus 1 by R2 plus 1 by R3.
Yes, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. In a parallel combination, the equivalent resistance can be calculated by 1 by R1 plus 1 by R2 plus 1 by R3. That is equal to 1 by 2 plus 1 by 4 plus 1 by 6. So here the denominators are not same. So we can make a common denominator by finding the LCM. So what is the LCM of 2, 4, and 6?
12.
I'm 4.
2, 4, and 6. What is the LCM?
12.
Yes, it is 12. LCM is 12. So we need to make the denominators as 12. So it becomes 6 by 12 plus 3 by 12 plus 2 by 12. 6 plus 3 plus 2 by 12, that is equal to 11 by 12. So 1 by Rp is equal to 11 by 12. But here we want to calculate the equivalent resistance in parallel combination, which implies Rp is equal to 1 by Rp is equal to 11 by 12, which implies Rp is equal to 12 by 11, that is equal to 1.09 ohm. So the answer is 1.09. So point is to whom?
Boys.
To boys, right?
Next answer. Very simple.
Okay, then the question can be given to girls. Okay, anyway, the question is to boys. Which of the given is the SI unit of electric current?
Who?
Anyone?
Current. 1 minute. Ampere.
Ampere is the right answer. The SI unit of electric current is ampere. The next question is to girls. The second question. SI unit of resistance. For girls, SI unit of resistance. Ohm. SI unit of resistance is ohm.
For that.
SI unit of resistance is ohm. The first question is to boys. The relation between potential difference V and current I is, options are, V is directly proportional to I square, V is directly proportional to 1 by I, V square is directly proportional to I, V is directly proportional to I. Option D, right. So here we have the options. V is directly proportional to I square. V is directly proportional to 1 by I. V square. V square is directly proportional to I, and V is directly proportional to I. So according to Ohm's law, we know that potential difference across the ends of a conductor is directly proportional to current flowing through the conductor whenever the temperature remains a constant. That is, V is proportional to I. So option D will be right. Okay, so boys team scores 1 marks. The next question is to girls. On which of the given resistance does not depend? On which of the given resistance does not depend? Length of the conductor, area of the cross section, temperature, density. Density, exactly. So the option number D is right. We know that R is equal to rho into L divided by A. R is equal to rho into L by A. Okay, so there are factors affecting by the resistance are length of the conductor, area of cross section, nature of the material, and temperature. So the density is the right answer. Okay, very good, girls. Now the next question is to boys. I think it's a simple question. All the questions are simple to boys, right? Next question is to boys. In SI unit, joules per coulomb is equal to volt, Newton's law, Pascal, and omega.
Volt.
How you obtain the answer? Explain it.
Volt is equal to joule by coulomb.
Yeah. Volt is equal to work divided by charge. That is, SI unit of work is joule. SI unit of coulomb is C. So the volt is equivalent to that of the joules per coulomb. JC raised to -1. Right. So the answer will be the first option. Okay. Then the next question is to girls. Commercial unit of energy. Commercial unit of electric energy.
I know.
Kilowatt hour.
Kilowatt hour. Very good. Kilowatt hour. The SI unit of energy is whatever, but here the question is commercial unit of electrical energy. Commercial unit of electrical energy is kilowatt hour. The next question, I think it is a repeated question. The unit of electrical resistance is ohm. We have already discussed this question here. So that question is rejected. Okay. So now what about our point 11? Boys scores 1, 2, 3, 4, 5, 6.
I think it will be wrong.
Girls 1, 2, 3, 4, 5. Okay. Now we have 2 more problems. This is a common problem. And who answer this question? That group will scores 1 marks. A potential difference of 100 volt is applied across a resistor of resistance 10 ohm. Find the heat energy produced in 10 seconds. It's a common question. Those who know the answer, say it. Then that group can score 1 marks. A potential difference of 100 volt is applied across a resistor of resistance 10 ohm. Find the heat energy produced in 10 seconds. Here we want to calculate the heat energy generated in the circuit. Heat energy.
I'm going to put a potential difference equation.
10,000 joule.
10,000 joule. Yeah. Right. What is the equation for calculating the heat generated in a circuit? H is equal to
I square RT.
I square RT. H is equal to I square RT. Right. And what are the parameters given here? V is equal to 100 volt. And resistance R is equal to 10 ohm. And the time is also given. Time T is equal to 10 seconds. Right? But the equation is H is equal to I square RT. Here the term voltage is not provided. So we can convert this equation in terms of Ohm's law. We know that I is equal to VR. V is equal to IR, right? V is equal to IR or I is equal to V by R. I is equal to V by R. Then what is I square? What is I square then? If I is equal to V by R, what is I square?
Square is equal to R by R by.
No, I square. I is equal to V by R. Then what is I square? Just to square that terms, then it becomes V square by R square. Okay, so according to Ohm's law, we know that I is equal to V by R, which implies I square is equal to V square by R square. Okay, so I substitute the value of I square here. It becomes H is equal to V square by R square into RT. So here 1 R from the numerator and 1 R from the denominator cancels. So it becomes H is equal to V square by R into T. So the equation for calculating the heat energy developed in a circuit becomes H is equal to V square by R into T. Again, what is V? 100. So 100 square, V square. So 100 square divided by R. R is 10 ohm into time. T is also 10 seconds. So this 10 and 10 cancels. So we get 100 square. What is 100 square? 10,000. What is the unit of heat generated in a circuit? It is 10,000 joule. Joule is the unit of heat energy. So the answer is 10,000. Point goes to boys T. Heat energy developed in a circuit is given by H is equal to I square RT, but in the given question, current is not provided. So we just convert the term current in terms of voltage. According to Ohm's law, we know that I is equal to V by R. So I square is equal to V square by R square. We substitute this equation here. So
And
H is equal. Yeah, yes, Fizan.
where ma'am getting this question is from Google questions.
Yes,
And where ma'am getting like this questions from like that. Small.
I'm just searching so many, referred so many books from guides. We get so many like of questions, practice problems are there. So H is equal to V square by R square into RT. Here we can cancel these two R. So it becomes H is equal to V square by R into T. Substitute all the values. So we get 10,000 joules. So point again goes to boys team. Don't worry. We have one more problem. The last question. How many joules are there in 1 kilowatt hour? Girls, quickly. I need the answer from you. Yeah. 1 kilowatt hour is equal to anyone. Yes.
1,000 kilowatt hour.
No.
And 3.6 into 10 raised to 90.
3.6 into 10 raised to
90.
10 raised to 19 is wrong. 10 raised to 6 joules. The 10 raised to 6 I heard from girls. Right?
No, ma'am.
Sean.
Is it from boys?
Yes, ma'am.
Okay. 3.6 into 10 raised to 6 joule. Not 10 raised to 19. 10 raised to 6 joules. Okay. Anyway, the point goes to boys. So total you have 1, 2, 3, 4, 5, 6, 7, 8. Girls, 1, 2, 3, 4, 5. So who wins here? No, it's boys. Okay. So this is a very quick revision of this chapter, electricity.